So we did this one together. On this one, remember they gave us the period, and we have the formula. Remember we learned yesterday? The period for tangent is different than the period for sine and cosine. The period for tangent is just pi. So the formula is written right up here at the top. Oh, it's a little behind. The period is pi over b. So when they give you the period, that means I have to calculate my b value. So I'm going to do it over here in the little function box. It is a lot behind.
Oh, wow. This is weird. Oh, wow. Is it fun? Yeah. The lab is exact.
She hasn't even started writing yet.
All right, so period equals pi over b. So 1 equals pi over b. Which just means with a little bit of algebra, like clear the b, that b equals pi. It's not it doesn't usually lag this bad, so I'm not sure because I've used it before.
Okay.
I guess we missed a few steps.
So I'm not sure. So maybe it's back on. Nope. Okay, it's not as bad as it usually is. Okay, so now I figured out b. Is there a shift right or left?
No.
How do we know there's not?
Because everything's on the
origin.
It's at the origin. So there's no shift, so that means their c value is 0. Is there a shift up or down? No, for the same reason, because the inflection point is right at the origin where it's supposed to be. So when I go to write this, it's y equals, the a value comes first, and my a value is 1, so you don't have to write 1. Tangent, and then your b value goes before your x value. My b value is pi. Yep. It is recording. That's why I did it.
Wow.
What I wonder is it recording my voice?
I was wondering that too.
Like,
when I do it, I don't turn my volume up.
Is it recording my voice at the same time as my hand is moving, or is the voice recording lagging also?
You should pause it and see.
You know, like so I'm going to be saying something but not doing it until a few seconds later. That would be really
You should
irritating.
pause it and see what
Well, I'm
happens.
paying attention.
Okay. All right. So let's do this one. It gave me a period of 4. So we have to calculate our b value using our formula. So
Yeah, we did. We got 817.
Oh, so then you're
So now I'm going to clear the b by multiplying both sides by b. So I have b times 4 equals pi. Then I'm going to divide by 4.
She just put on the
So my b value is pi over 4.
This is better.
So the projector is projecting the future.
That's the past.
It's the past. All right. Is there a horizontal shift?
Two.
It's a shift of 2. Can you tell whether it's right or left?
No.
Does it matter?
No.
Not really. So it doesn't really matter what we put our shift as. I'm just going to put 2, and we'll decide when we make the equation. Is there a vertical shift?
No.
So y equals, my a value is 1, so I don't have to write that. Tangent of your b value, 2.
This is such an independent way to do this.
I don't think I've ever enjoyed math more than like hearing the words, thinking about the words, and then watching what happens. It gives me time to process.
There we go.
You know what? Yeah.
This is Quinn's new way of
Are we
learning.
good? Are we
I
good?
need to watch all school from now on, just like 12 frames behind.
Behind the
This is
audio.
way more than 12 frames.
So on number 18, 18 and 17 have the same period. So that means they are going to have the same B value as well. So we don't have to recalculate it. We can just know that our B value is pi over 4. Is there a horizontal shift on 18?
No.
So it's 0. Is there a vertical shift?
No.
All right. So this one is simpler
This
than
is
the
like
one
we
above
should
it.
buffer check.
It's 13 seconds behind.
Oh my gosh.
Exactly.
I counted it.
Hey, why did y'all let me mess up the one above it?
What?
What?
I put 2 right there and it should be pi over 4.
What the freak?
Huh?
Because half the time we can't tell what
why
you're doing until it's already done.
That's true.
We can't be like, hey, correct this.
Oh, yeah, 'cause you said it and I just didn't.
Yeah,
realize it
because
was
it has the
wrong,
same
but I, like,
period.
didn't fully comprehend
The
it.
period is 4, so.
I do need both audio and visual.
Oh, yeah.
I really hope it's recording our voices so we can catch that.
When I-
Oh, it'll definitely, y'all's voices will definitely be on there.
Oh,
So,
perfect.
Yeah, I'm gonna be sitting there, so, oh yeah, we're so funny.
I'm not
Like,
done.
we
I'm
watch
the
the
Sam
biggest
body
of the
work.
different.
Hayden is stupid.
all right, we're going to
Also, dogs might
skip over the next page because the next page is secant. We haven't learned what secant looks like in the first place. So we're going to skip that. Skip the next page because it is also secant. And then go to the back. We didn't do any cotangent graphs, but cotangent works the same as tangent. So remember yesterday we had 5 critical points that we were adjusting. We had an asymptote, then we had an anchor point, an inflection point, another anchor point, and another asymptote. They're giving us the exact same thing for cotangent right there,
Whoa.
right up here.
Whoa.
There's my asymptotes. There's your first anchor point. There's your second anchor point. Oh, sorry, that's your inflection point. And then the last one's your third
Okay, I
anchor.
was about to say, you're not making sense of what you're
It's
saying.
It's because it's making me laugh. Okay. Okay. So if you look at number 28, I have 2 transformations happening. The 2 in the front and the +1. So remember, if there's no parentheses, they mean that the parentheses close after the X and then comes the +1. So are these 2 changes X changes or are they Y changes? Or both? Or one of each? They're both Y changes. So if that's true, are my asymptotes going to change at all?
Yes.
No, because look at what your asymptotes are. They're X equals something. So they're X's. So they're not changing because only Y values are changing. So my asymptotes are still going to be at negative pi, 0, and pi. So you can go ahead and sketch in an asymptote at negative pi, 1 at 0, and you can't really see pi, but it's the last line on here. Of my key points, the X values aren't changing. So I'm going to go ahead and write the parentheses and the X value of each one because they're not changing anyway. Because these transformations are only Y changes.
I thought for a second it might have been caught up because you were writing. It was writing.
Yeah.
All right, now I have 2 things that are going to change my Y value. We still have to follow order of operations. So I have a multiply by 2 and an add 1. You have to multiply by 2 first and then add 1. So my first Y value up here is 1. I'm going to multiply by 2 and then add 1. So this is going to be pi over 4, 3. And I can go over and put a dot at pi over 4, which is the first line to the right of the axis, and up at 3. My second Y value is 0. So I'm going to multiply 0 times 2, which is 0, and add 1. So it's just 1. So I have the ordered pair pi over 2, 1. So I'm going to go to pi over 2 and up to 1 and put a dot. My last ordered pair I have the -1. I multiply that by 2 and get -2. Add 1, which gives you -1. I'm going to go to 3/4 pi -1 and put a dot. And then you remember what it looks like. Now, the pattern repeats itself, so I could go over here and do the exact same pattern because I know that the pattern repeats itself over and over and over again because it's periodic. Okay, are y'all okay, sort of? All right, so on number 29, I have a 2. That 2, if this was a calculator, it would you would have put cotangent and a parentheses would have automatically popped up. That 2 is inside the parentheses with x. So is that an x value change or a y value change? An x value change. And it does the backwards thing. It looks like it's being multiplied by x. But in fact, it's being divided. So my asymptotes are x values, so they are going to change. I'm going to have to divide them all by 2. So it's going to be -pi/2. 0 divided by 2 is still 0. And pi/2 are my 3 asymptotes. You can go ahead and sketch those in. And once you know the pattern, I have an asymptote every 2 bars. I could sketch in extra ones because this is periodic and it's going to repeat itself the entire time. All right, so for my key points, the x values are changing. They're all being divided by 2. So remember, when you have a fraction, dividing by 2 is the same thing as multiplying by 1/2. So that first key point, that is pi/4, is now pi/8. So I got this pi/4, I'm multiplying by 1/2, so it will be pi/8. Your y value isn't changing, so it's going to be pi/8, 1. I'm going to graph pi/8, 1. My scale is scaling by quarter pies. So pi/8 is going to be halfway between 0 and that first line. Would be an 1/8. So right there, if you can see it. My second ordered pair is going to be pi/4, 0. And then 3 pi/8, -1. And again, once you know the pattern, you could repeat the pattern next to it because you know what it looks like. You can repeat it over and over and over again. You don't have to. If you just do 1, I know that you know that it's periodic and it's going to repeat itself. Okay, so take a second and try number 30. I'll give you a minute. Because this has to restart at 15 minutes anyway. So I will stop it and I will start it again. And maybe when I start it again, it'll be on track.
We should, once it stops, we should watch it to see how far off the video is from what you've been writing.
I do want to know how often.
I want to know too. We'll see.